Welcome to another of my videos where I work through and explain A-level physics multi-choice questions. If you want to try to answer this question yourself, pause the video now. If you got the answer B, you should feel very pleased with yourself. If you'd like to hear my explanation of how I found the answer, please continue watching. So a muon and an antimuon annihilate to produce the minimum number of photons. What is the maximum wavelength of the photons? Well, we're talking about an annihilation reaction. We're going to take a muon and an antimuon. They come together and annihilate each other. Now, there has to be at least 2 photons produced, and that's in order to conserve momentum. The muons have momentum, they're traveling in opposite directions, so we can sort of assume overall there's 0 momentum when we add the positive and the negative momentum vectors together. And believe it or not, photons have momentum as well. I know they don't have mass, they have momentum, all due to do with Einstein's theory of relativity. So if we only had one photon, then obviously there would be overall momentum. We need 2 photons moving in opposite directions to give overall 0 momentum. Where's the energy coming from for these photons? Well, the rest energy of the muons is going to be transferred into the energy of the photons. So the first thing we need to find out is how much rest energy there is to play with. And we're going to need to look at the data sheet. And it says here on the data sheet, I've got the relevant page here, that a muon has a rest energy of 105.659. I'll round that to 106, but 106 mega electron volts. Well, the first thing we're going to need to do is convert that energy into joules. So if I have 2 muons, then I'm going to have 2 times that amount of rest energy. So the rest energy I have is going to be 2 times 106 mega electron volts, but I need to multiply that by the charge on the electron to find the amount of energy in joules. And that's going to give me 3.4 times 10 to the minus 11 joules. Now, because I got 2 photons, each photon can only have half that amount of energy. So the amount of energy I'm actually going to be playing, the amount of energy in each photon is actually going to be 1.7 times 10 to the minus 11 joules. To find the wavelength of the photon, I'm going to use the equation from your data sheet that the energy of a photon is equal to the Planck constant multiplied by the speed of light over the wavelength. Rearranging that, I get the wavelength is equal to Planck constant multiplied by speed of light over energy. We put some numbers in. Planck constant you get from your data sheet again, 6.63 times 10 to the minus 34. Speed of light, it is on your data sheet if you can't remember it, 3 times 10 to the 8 meters per second. And we're going to divide that by the energy for each photon, which is 1.7 times 10 to the minus 11 joules. And that's going to give us a wavelength of 1.2 times 10 to the minus 14 meters. Answer B. Now, if you'd been wise, you would have spotted that there was a shortcut I could take here. I didn't actually need to multiply the rest mass of the two muons, or the rest energy of the two muons, because I would then need to divide my answer by 2 because that energy had to be shared between the two photons. So I could have just said each photon gives all its energy to one. Each muon gives all its energy to one photon. That would have been a slight shortcut. Okay, I hope you found this useful. If you did, please press the like button. All comments will be welcome. I hope you'll share and watch more of these in the future.